Okay, perpendicular bisectors, graphing equations of parallel and perpendicular lines. So for the, just want to point something out on this. Like, I'm giving you step-by-step directions of how to solve this problem, but on the test, you're just going to be given something like this. All it's going to say is perpendicular bisector, and it's going to have 2 points, and you're wanting to find the equation of the perpendicular bisector of this segment. So you're wanting to find the equation of the line that is perpendicular, so you need to first find the slope, but also goes through the middle of the segment, and the way to find that is the midpoint, because a bisector cuts a segment in half. So just make sure that you guys are aware, like, you will have to know what the word perpendicular and bisector mean and how they affect the way you approach this problem, because you won't be given step-by-step directions on the test. Okay, so just want to make that clear, because I know in the past that has been a struggle for people. We're going to find the slope and the midpoint of this these 2 points real quick. 3 minus -4. We've done this a lot in the past few days. Remember, when you're subtracting a negative, it becomes a positive, so this is 7/2. That is our initial slope. That's the slope of this segment that we're trying to cut in half and put a line through it at a right angle. And then the midpoint is going to be, add your x's together, so 5 plus 7 over 2, -4 plus 3 over 2. So 5 plus 7 is 12. Cut that in half, you get 6. 12 divided by 2 is 6. And then -4 plus 3 is a -1 divided by 2. I mean, I would suggest that you guys check your work with, like, anytime you're adding and subtracting integers, check your work on the calculator, because tiny little mistakes like this, like maybe you accidentally make this a -1 instead of a 7, and then it just ruins the entire problem, okay? So I would suggest figuring it out in your brain and then also typing it into the calculator and then seeing if they match. That way, maybe if you accidentally type it in the calculator wrong or accidentally make a mistake when you're adding it together, that can be figured out, okay? Because those tiny little mistakes are so frustrating. And then you have your slope, you have your midpoint. We don't want the slope of this segment. That will not give us the perpendicular bisector. So we need to change this to the perpendicular slope. So remember, that symbol means perpendicular. We talked about that yesterday. We talked about finding perpendicular slopes, where we change the sign and flip it. So these are the 2 things that we need, the perpendicular slope and the midpoint, that we're going to bring down here in order to solve this equation. So 6 and -1/2 is our midpoint. We need that. Our perpendicular slope is -2 over 7. We need that. We are going to take these 3 things, well, I guess they're 3 numbers, plug them into y equals mx plus b, and solve. One thing I want to tell you guys before I solve this is going to be kind of an ugly one. The one that you do independently next is going to be a lot prettier. So when you see all the fractions in here, please don't get overwhelmed and shut down and be like, I can't do this, because the one that you're going to deal with next is going to have whole numbers. But again, I like to show you examples that are more challenging, so it makes the ones that you do on your own feel a lot easier. So the perpendicular slope that we're going to use is -2 over 7. We're going to plug that in for m. For our y, we're going to plug -1/2 in. My m is this, -2 over 7. My x is 6. There it is. I've plugged all the things in. Now I'm going to multiply. -1/2 equals -12 over 7. Where did the 12 come from? All it is 2 times 6. Okay, then I'm going to add 12 over 7 on both sides. Why am I doing this? Because I'm trying to get b all by itself. So I need to figure out what these 2 things are added together. I'm going to show you like how to add these fractions, and then we're going to check it using our calculator, okay? So when I'm adding these fractions, -1/2 plus 12 over 7, so see how this was -1/2, that's 12 over 7. I need a common denominator. When I look at this, I'm like, okay, well, 2, and then it goes goes 4, then 6, then 8. So it doesn't, you can't multiply 2 to get 7, 7's odd. But what you can do is multiply the two denominators together, and you get 14. And then that can be your common denominator. So if you have 14 on the bottom of both of these, you just have to figure out what the numerator is. So what do we multiply 2 by to get to 14? We multiplied 2 times 7 to get 14. So we need to multiply the top part by 7 as well. And if you look at that, I mean, it kind of makes sense because 7 over 14 does simplify to 1/2. We're not actually changing the fraction at all. And then for this one, it's 24 on top. Why is it 24? Why do we not multiply it by 7? Well, because you've got to multiply it by whatever it takes to get this denominator to 14. So that's 2. So we're going to multiply the top and the bottom by 2. So 12 times 2 is 24. 7 times 2 is 14. And then now we can just negative 7 plus 24, so it's going to be a positive number, is 7 over 14. If this just totally freaks you out, the calculator will do this for you, okay? So you just have to make sure you can do this part correctly. But in the calculator, you can type in the little fraction bar, negative 1/2 plus 12 over 7, and you get 7 over 14. The calculator would not do it, like if you mess up and accidentally subtract this instead of add, it can't figure that out for you. But it can add and subtract fractions for you. So that is my B value, and you know, don't stress. The example we're going to do next, the B value comes out to a nice pretty whole number. So we're going to use y equals my slope times x plus 17 over 14. And then that's my final answer for this. So what did we just find? We just found the line that cuts this segment in half at a right angle. That's what perpendicular bisector does. Cuts the line in half at a right angle. And we just found the equation of that line. So what we're going to do is we're going to come down here, and I'm going to pause my screen, and I want you to solve for, so we're going to solve for just the slope and the midpoint first, and then I'm going to have you guys check it. And that way if you make a mistake, you can fix that there. And then we're going to go through the rest of the process, make the slope perpendicular, plug it into the equation, and then that's it for this page. Okay, so I'm going to pause my screen. I want you to find the slope and the midpoint. All right, so this is the midpoint, this is the slope. Kind of check and see what you have. If you made a mistake, figure out where that is. But I didn't want you to go into solving the rest of it and have the wrong slope and midpoint. So the midpoint is 2, negative 1. The slope is 2 over 7. So your job right now is to change this to a perpendicular slope. So I'm going to pause my screen again. I want you to change this to a perpendicular slope and then use this point to do the y equals mx plus b. So plug the point in as well as that perpendicular slope. Okay. So first of all, make sure you made the slope perpendicular and you did not plug in positive 2 over 7. If you did that, you got issues. And then when you multiply these, you can skip this step, but I'm just showing you what's happening. 7 and 2 is 14, and then that simplifies. If you went, you know, straight from here or here to here, that's fine. Oh, goodness. And then next, you're going to add 7 on both sides. Your B is going to be 6. So check and see if you got 6 for B. If you did, awesome. If you didn't, as long as you figure out your mistake, that's okay. Like, the point of this is to learn, and typically mistakes help you learn. Oh, I put B. I meant to put 6. So let me change that. I guess they look similar. So I use the perpendicular slope, not the original slope. And then I use 6 for my B value. And that is the perpendicular bisector. All right, we are drawing 2 lines here. One of them is going to be parallel, and one of them is going to be perpendicular on the graph. So in order to figure out, you know, parallel and perpendicular lines, you need the slope and the perpendicular slope. This slope right here, so we talked about horizontal lines and how they have a slope of 0. Try not to get that mixed up. make sure you realize this is not undefined. If you put Bob on this horizontal slope, he walks to the right, then he's fine. He's not going up or down. There's no change in the slope. It's 0. It's not undefined. But the perpendicular slope is undefined. And I feel like that is kind of a mental block for some people because they want to flip the fraction and they want to change the sign, but you don't do that in this case. So the original equation of our line, I'm also going to write that down here, is just simply y equals positive 8 because it goes over the y-axis at 8. When you're drawing these lines, so you can kind of pick anywhere. There's really not one exact answer that it needs to be, but you're just going to draw a perpendicular line. Remember that these vertical lines, it's x equals wherever on the x value it is. So this one's perpendicular. And then for the parallel line, you can draw it anywhere you would like. Just, wherever you want. But it is going to be parallel to this line. And those little arrows are the symbol for parallel. And the equation of this line is y equals 5. But you could have drawn it down here. You could draw it here. It doesn't matter where it's drawn. So yeah, make sure you have the perpendicular and parallel one. I feel like is the one that gets mixed up a lot. All right, I'm going to pause my screen real quick. And let's find the slope of this one. So our initial slope is -1, perpendicular slope is 1. My equation is y equals -x, so I use that initial slope, which would make that a -x, and then plus 4. Where'd that 4 come from? That is where the equation, or where the line crosses the y-axis. And your B is your y-intercept. So we're going to look at this. I'm going to draw a parallel line first. In order to do that, you put a point literally anywhere on your graph. It doesn't matter. And then you are going to use that slope to go down 1 over 1, and I'll put another dot. I might even put a third dot. On delta, it only lets you do from one to the other. But it helps you to draw this. And this is going to be my parallel line. Is it drawn perfectly? No, it's not. But it has a slope of -1. It is parallel to this. And then for my positive slope, I pick a point and put it literally anywhere. And then it just needs to go up 1 over 1. Up 1 over 1. Draw in that perpendicular line, and then you can draw your little box to show that it's perpendicular. So the way that you find this goes up 1 over 4, and then you flip the fraction and change the sign so it becomes -4. And my initial equation is just y equals 1 over 4 for the slope times x plus 4. Where's this come from? It's the y-intercept. That's the plus 4. All right, and then to create a parallel line, I just put a point anywhere on the graph. And then I count up 1 over 4, put another point, and then I can graph my line. And that's what you're going to do on delta as well, because you're going to put 2 points, and then it'll put a line in between for you. So that is my parallel line, but the point can go anywhere. You just pick a place on the graph to put the point, and then count up 1 over 4, because that's the slope. And then you have a parallel line. And then same thing for the -4. Pick a point anywhere. Go down 4 over 1, because -4 goes, the rise of the run is -4 over 1. And then you have a perpendicular line that is drawn perpendicular to that initial line. But yeah, just remember you're going to, ultimately you'll have 2 points, and these points need to, the way you determine where they go is by just counting the slope. That's all you're doing.